Hi guys, Miss O'Connell here. So I received a question via email about how to convert hertz to seconds. So instead of answering that student individually, I figured I would record a video in case anyone else is also confused. So technically, the definition of a hertz, which was discussed in the previous video, is 1/second. So hertz is the inverse of a second. So we don't technically convert to hertz. Technically, we're converting from period to frequency. So the definition of period is the time it takes for one vibration, oscillation. Okay, again, those two words mean the same thing. Frequency is the number of vibrations or oscillations per unit time. So that's the definition of what frequency and period are. Mathematically, they're technically inverses of each other, right? If we take the inverse of the period, we get the frequency. If we take the inverse of the frequency, we get the period. So there's two ways that you can approach solving a problem if you're given oscillations and time. Okay, so let's take a look at a second example. So a pendulum oscillates 5 times in 6 seconds, meaning it swings back and forth 5 times, and it takes 6 seconds for 5 vibrations or oscillations to occur. We need to determine the period and the frequency of oscillation. So what we're given is number of oscillations and time. The period is the time it takes for one complete oscillation or vibration. The frequency is the number of oscillations that occur per unit time. So we can either use, in this case, we're going to use the definition of what period is, the time it takes per oscillation. To figure out how much time it takes for one oscillation, we have to divide the total number of seconds by the total number of oscillations to get the time per one oscillation, right? So technically here, right, this is an implicit one, right? We have 1.2 seconds per one oscillation. Okay, which we leave as just 1.2 seconds. Okay, so alternatively here, now that we have the period, we can either use the definition of frequency or the equation for frequency in terms of period in order to find the frequency. So I'm going to stick to the definition. Okay, so one way in which you can calculate frequency would be to take the number of oscillations per unit time, which is seconds. Okay, so you take 5 oscillations, divide by 6 seconds. 5 divided by 6, we get 0.83. Technically, our units are 1/second. Right? The definition of 1/second is a hertz. So the frequency is 0.83 hertz. Okay, it's not technically a conversion, it's the definition of what a hertz is. Right? Just like the definition of a Newton is a kilogram meter per second squared. Okay, so the definition of a hertz is 1/second. So as you divide number of oscillations by time, you get hertz. Okay, a second way in which you could have solved part 2 for frequency is using the equation for frequency in terms of period. So knowing that one oscillation occurs in 1.2 seconds, to find the frequency, you can take the inverse, so you divide 1 oscillation by 1.2 seconds, the time it takes to make the oscillation, and you get 0.83, the units are still 1/2 which is the definition of a hertz. The frequency is 0.83 hertz. Okay, so I hope that helps clear up that question. So we're not converting from hertz to seconds. The definition of a hertz is 1/2. Okay, let me know if you have any further questions.